Hi class, this is section 4.8. It is the last section in this chapter that we are going to talk about, and it has two conjectures. So you are going to need your notebooks to add two conjectures, and you're also going to need Sketchpad. This first conjecture is vertex angle bisector conjecture. It says, in an isosceles triangle, the bisector of the vertex angle is also blank and blank. So after we do our constructions in Sketchpad, I'm hoping that you will easily be able to fill in these blanks. So to do that, we're going to have to open Sketchpad, and we're going to construct an isosceles triangle. So I'm going to start with a line segment. And then I'm going to find the midpoint of that line segment. And through that midpoint and segment, I am going to construct a perpendicular line. Now, whatever point I put on the perpendicular bisector will make the two sides of the isosceles triangle. So construct segment. I can go ahead and measure that length to prove that it is isosceles. Construct the other side. And I'm going to go ahead and measure it. Now, no matter where I slide A to, my triangle stays isosceles because I constructed it that way. Okay, so I am going to hide the bisector. And let's see what happens. So if you remember, our conjecture says in an isosceles triangle, the bisector of the vertex angle. So we want to bisect the vertex angle. So we need to remember the different pieces of an isosceles triangle. So this side over here is a leg. This side over here is also a leg. Down here, this is called the base. So the angle across from the base, remember our base angles are congruent. We could mark them that way. But my vertex letter A is the vertex angle. Okay, so there's our isosceles triangle. I am going to bisect this vertex angle. Notice what happens. It goes right back through the midpoint of the base and is the same line as the perpendicular bisector that I used to construct the angle. If I measure just this angle here, because we constructed it as a bisector, it'll show that these two angles are congruent. Okay, so we have line segment AD that we have made by it being a bisector. It's also perpendicular. So this segment AD is also the median, an angle bisector, and an altitude. So if I measure these base angles down here, you will see that they are 90 degrees. Okay, so line segment AD is a median, angle bisector, and an altitude. Of the isosceles triangle ABC. Okay, so if you want to take a picture of this and put it in your notes, that would be great. It's going to go with conjecture 27. In an isosceles triangle, the bisector of the vertex angle is also the median and an altitude. Remember what a median and an altitude do. A median goes from the vertex to the midpoint of the side opposite, and an altitude goes from the vertex to the side opposite, forming 90-degree angles. So if you have an isosceles triangle, you're going to have a lot of special things. You already know that the base angles are congruent. Now if you bisect the vertex angle, you know that you have a perpendicular line and it's hitting the midpoint. Okay, so for the next conjecture, we're going to talk about an equilateral triangle. For every equilateral triangle, it is blank, and conversely, every equiangular triangle is blank. So I'm going to go back into Sketchpad and we're going to make an an equilateral triangle. So hopefully you remember to do that with your circles. So there are my two circles. I then find the intersection points. We need to do one because I'm just making a triangle. So now I highlight the points and I can construct segments. Let's go ahead and measure them while they're highlighted. And I'm going to hide my circles. Okay, so I have my equilateral triangle. I can move it around, it stays equilateral. Now I'm going to measure the angles. Maybe. Excuse me. That first angle A is 60 degrees. Angle C is 60 degrees. And angle B is 60 degrees. So in every equilateral triangle, it is also equiangular. Equilateral and equiangular. If it's one, it has to be the other. So if you want to type yourself a note, you can take a snapshot and put this into your notes. So every equilateral triangle is equiangular, and conversely, every equiangular triangle is equilateral. And those are our conjectures for today. I want to talk about one other thing, and the fact that that last conjecture is a biconditional. The equilateral equiangular triangle conjecture is a biconditional statement. Both the statement and its converse are true. A triangle is equilateral if and only if it is equiangular. That means you can read that statement either way. You can say if equiangular, then it's equilateral, or if it's equilateral, it's equiangular. One condition cannot be true unless the other is true. So when that happens, it is called a biconditional, and you can write it as an if and only if statement. So an equilateral triangle is also equiangular and an equiangular triangle is also equilateral. So to write that as a biconditional, a triangle is equilateral if and only if it is equiangular. So that completes our section 4.8, which is the last section of the chapter. On page 245, I'd like for you to do numbers 1 through 5. We'll see you in class tomorrow.